Next topic is queuing theory. Queuing theory, you may get 1 or 2 marks. So, what is queuing theory? Queuing theory deals with the study of queues. So, the fundamental behavior of queues is called queuing theory. Okay. Queuing theory deals with the study of queues. You may have seen long queues near cinema theaters and even grocery stores, so many places wherever more demand for an item is there, definitely people will wait in queue. So here the queuing theory discusses similar thing in terms of machines. The machine has to wait in queue for the operation. Suppose if a machine has to undergo first turning, then drilling, then grinding. So in turning it has undergone, after completion of turning in a lathe, then it has to go to drilling. In drilling there are 10 components waiting, workpieces. So it has to go and wait in the queue till all the 9 components has to complete their drilling operation. Then then it will get the chance. So there how much time it has to need to wait. So what is the technique we need to use? What are the precautions we need to take to reduce the waiting time? All this we discuss in queuing theory in a mathematical form. So that's why it is also called the mathematical behavior of queues. Mathematical behavior of queues is called queuing theory. The scientist Erlang invented the queuing theory concept. That's why it is also called Erlang's theory. Here, characteristics of queues. The characteristics of queuing model is characteristics of queuing model is arrival pattern, size of the input source, arrival pattern, departure pattern, priority rule, customer behavior. These are the characteristics of the queue. So this arrival size of the input source can be considered as infinite, and arrival pattern of the system, number of how the customers are coming, arrival pattern, whether they are coming like um, continuously or normal distributedly or Poisson distributedly or wow. So arrival pattern in the system. Arrival pattern at system. System here means queue, waiting and as well as work the processing. So arrival pattern tells how the customers are arriving in queue. Sorry. The arrival pattern can be either deterministic or probabilistic. If it is deterministic, it is denoted by D. If it is probabilistic, it is denoted by M. Probabilistic arrivals follow Poisson's distribution, and the number of arrivals per unit time is estimated by the Poisson's distribution. The probability distribution of inter-arrival times is the time between the two consecutive arrivals. It follows exponential distribution. The discrete Poisson, as we have told, that the arrival pattern follows Poisson distribution. So that's why one can show mathematically that the probability of distribution of inter-arrival times is exponential. So arrival patterns tells how the customer are arriving in queues. So this can be arrival pattern can be deterministic as well as probabilistic. Deterministic arrival pattern is denoted by deterministic arrival pattern is denoted by D. Probabilistic arrival pattern. These are important in terms of Kendall's notation. Is denoted by M. So we generally discuss probabilistic only. If it is deterministic, what is the point of talking? Whenever it is generally all natural activities happens in probabilistic, we can't expect the behavior, so we know only this behavior follows a certain distribution. So probabilistic arrivals follow probabilistic arrivals follow Poisson distribution. So this Poisson distribution in arrival rate is given by number of arrivals per unit time. Arrival rate lambda is equal to number of arrivals per unit time. So that Poisson distribution, as we told, p of x equal to e power minus lambda power x by x factorial, where for x equal to 0 comma 1 comma 2 comma till n. So p of x is the probability of arrival probability of arrival X is the number of arrivals per unit time. Number of arrivals. Lambda is arrival rate, average arrival rate or arrival rate. One by lambda is the reverse of the time between the arrival rate. Mean time between arrival rate. It is also called inter-arrival time. If arrival rate follows Poisson distribution, so inter-arrival time follows exponential distribution. Inter-arrival time follows exponential distribution. When the probability of number of arrivals follow Poisson distribution, inter-arrival time follows exponential distribution. That exponential inter-arrival time is given by exponential distribution is given by P of t equal to lambda into e power minus lambda t, where t is the inter-arrival time. Next is departure rate. Similar to the arrival rate, departure rate tells us how many customers are leaving from the system. Similar to arrival rate, departure rate tells how customers are leaving the system. It can also be the probabilistic and as well as deterministic. Similar to arrival pattern, deterministic is shown by D, probability is shown by M. So the probabilistic arrivals or departures are said to follow negative exponential distribution. The probabilistic departures. These points are important for one mark question. Are said to follow negative exponential distribution. Negative exponential distribution. So next one is queue size. The size of the queue may be considered as limited or unlimited. The queue may be considered as limited when the length cannot exceed a certain number. It may be unlimited also or infinite. Queue size is limited if the length cannot exceed length of queue cannot exceed certain number. Queue size can be unlimited also. That means infinite. So next is priority rule, which is also called queue discipline. This priority rule tells that how the customers are taken as service, how the customers receive the service. It tells how the customers receive service. Like for example, first one is first come first serve. So whatever the first, most of the queues services are follow this rule. Whichever customer comes first, he will get serviced first. This is also called first in first out. All FIFO, first in first out. The customer who comes first serviced first. So even in our daily queues also this rule mostly people will follow. Second rule is last come first serve. Last come first serve, or last in first out. So here the customer whoever comes last will be serviced first. The customer who comes last is serviced first. Next discipline is PCO, preferred customer order. Preferred customer order. Here the preferred customer is serviced first. Preferred customer is serviced first regardless of, without considering whether he comes first or last. Without considering when he came. Last one is SIRO, service in random order. Here in this, the customer is serviced at randomly. Next one is customer behavior. We have just discussed customer discipline, queue discipline. Similarly, customer behavior. So this tells how customer behaves in queue. It explains how customer behaves in queue. First one is balking. If the customer leaves the queue because due to the queue length, then there is no, because the queue is long and there is no enough space, then it is said to be balking. The customer leaves the queue because the queue is long, because the queue is long and there is no sufficient space, and there is no sufficient space to stand. Sufficient space to stand. So because of not availability of space, he leaves the queue. This is called balking. 2011, one more gate bit. Next one is reneging. If the customer leaves the queue due to frustration, is called reneging. If the customer leaves the queue due to frustration of long waiting, frustration or lack of patience due to waiting is called reneging. Jockeying. Jockeying is called JOCKING, shifting from one queue to another queue. If there are more number of queues, more than one queue doing the same service, so shifting one from one queue to another queue is called jockeying. So these three are customer behaviors. Next, Kendall's notation of queuing system. So Kendall proposed a set of notations of queuing models. So Kendall is a scientist proposed few queuing models. The way this actually they are used in the literature. The common note pattern for the notation of the queuing model is given by A, B, C, D, comma E, not comma slash. So this is a Kendall notation. So what is A means here? Where A equal to probability distribution of inter-arrival time. Probability distribution of arrivals. B, probability distribution of service. Also called service pattern. C, number of servers in the system. D, maximum number of allowed customers. Also called system capacity. How many people are allowed in the system, or maximum allowed customers in the system. There is another thing F also here. E equal to Q discipline. We have already discussed a few Q disciplines, which is also called priority rule. First come first serve, or whichever we are using, we have to show in this notation. Finite or infinite, last one. F generally very some cases they won't use. The Q is finite or infinite. Only first five are important. So whenever the customer comes in the system, arrival pattern, that is called birth process. Birth occurs whenever A customer arrives into system. It is said to be the birth of queue occurs, and it follows Poisson distribution. As we have already discussed that arrival pattern will follow Poisson distribution. Whenever a customer departures a system is said to be death process. It's called negative exponential distribution. A queuing model is said to be both and death and birth and death model. Departure process is said to be death process. So queuing model is said to be both combination of birth and death process. The queue is independent of time and is said to be transient in nature. And after some time, the queue forms. Independent of time is called unsteady state, steady state system. The single server queuing model. So before going to discuss single server queuing model, here Kindle's notation where we will show one or two examples. M1. Just he has given MM1 model. This means what is MM1 model? Poisson arrivals. M is a probabilistic. First M is Poisson arrivals. Departure is exponential service. Single server. One is single server. This is called generally single server queuing model.